Kia ora, Year 12. This is quite a tricky scholarship question from sometime in the 80s, and it's out of the old Delta book in exercise 5.8. We're given a condition. We're told that if sine of a plus b over cos of a minus b is equal to 1 minus k over 1 plus k, then if that's true, we have to prove that this thing here is also true. So I think there are quite a few ways to do this. If you Google this question, you'll find there are quite a lot of internet sites that have looked at this problem around the world. So it's not terrible, but it's also not a two-line thing. So get ready for some trig identity work and quite a bit of algebra. But in terms of how we're going to do it, what I'm noticing down here is I've got tan of this thing here, so this is pretty easy, is equal to k times cot of this thing here, which is also going to expand pretty easily, times k. And then up here, I've got this thing here, and I haven't got k equals, obviously. But I can work with this to make k the subject. And so that's going to be my strategy in this video. We're going to rearrange this, and then we're going to show that we can get this condition here. Right, so the first thing we're going to do with this is multiply through. So we're going to have 1 plus k times sine of a plus b is equal to 1 minus k times cos of a minus b. And I'm not going to do those expansions just yet, but I am going to expand out those brackets and just leave this how it is. That gives me sine of a plus b plus k sine of a plus b is equal to cosine of a minus b minus k cos of a minus b. I'm going to whoosh all of the stuff with k in it over to the left-hand side and all of the other stuff to the right-hand side. So k times sine of a plus b plus cos of a minus b is equal to cos of a minus b minus sine of a plus b divided by this here. And I'm going to write that in the order cos of a minus b plus sine of a plus b. Okay, so that's the first bit. Something's gone wrong there. Hang on. I've missed a whole line. I've gone way too fast. Let's just back up. Right. We're doing a proof, so we need some really good working. So k is equal to, this is why you should not do maths videos at 11:20 at night, but there you go. Okay, here, that's better. Okay, so now we've shown that that first condition can be rewritten as quite simply giving me an expression for k. Okay, now let's look at the next bit. If we've got that, we have to prove that this relationship is going to be true. Tan of pi on 4 minus b is equal to tan of pi on 4 minus tan b over 1 plus tan of pi on 4 tan b. And that cleans up really easily to 1 minus tan b over 1 plus tan b. That means that we could say straight away that tan of pi on 4 minus a, without going through all of that again, is going to be 1 minus tan a over 1 plus tan a. And that means that we can say pretty quickly that cot of pi on 4 minus a, which is what we want over here, is going to be the reciprocal of this thing here. So it's going to be 1 plus tan a over 1 minus tan a. All right, so looking back up here, if we now get rid of the mess, let's get rid of all of that. If we take this and we divide it by this, we're going to get some expression. Then we're going to work with that expression to show that if we keep working on it, we end up with k, which is this thing here. So my goal is to get through to like those 4 cos and sine compound angles. In here, we've got this tan of pi on 4 minus b over cot of pi on 4 minus a is going to be 1 minus tan b over 1 plus tan b divided by this thing here, 1 plus tan a over 1 minus tan a. So I'm not seeing any sines and cosines yet, but we're not too far off. So here we've got 1 minus tan b times 1 minus tan a, timesing by the reciprocal, 1 plus tan b times 1 plus tan a. Okay, so it's time to start expanding that out, but keeping one eye on where we're trying to get to. So we're trying to get through to here. But the first thing to do is just to do the obvious expansion. So 1 minus tan b minus tan a plus tan a tan b. 1 plus tan b plus tan a plus tan a tan b. But now we're getting somewhere because tan b is just sine b over cos b. So we're about to do, yet again, a whole lot of year 9 adding fractions. Well, kind of year 9. Oops, that's wrong. Sine A, not over sine A. Sine A over cos A. So I don't know if anyone's out there watching still. If you've watched this far, you get, I don't know, chocolate, something, a lolly there, cos B. But you have to tell me you watched this far. Right, so that's the top line done. And then the numerator's done. So now we do the denominator. 1 plus sine B over cos B. Now, as you're writing all this, hopefully your brain is going, I'm adding fractions. So I want to get a common denominator. And the common denominator here is going to be this. So that's my next step. Right, and I'm going to break it out. So I do this bit divided by this bit. So the first bit is going to be over cos A, cos B. Well, the 1 has to be times by both of those. This one just has to be times in. The sine B has to get multiplied by cos of A. Now, this is where you should be starting to get really quite excited, well, in a maths kind of way, because you can see in front of you the compound angles starting to kind of appear, but not quite in the right order yet. So I really like this question because it really makes you start to fully engage with the compound angle formulae. So now we're going to divide by, and we're going to do all of that here. And again, the common denominator will be cos A, cos B. And we're going to get cos A, cos B, plus sine B, cos A. So that's that one times the extra bit, plus sine A, cos B, plus sine A, sine B. Right, now we can clean that up pretty easily. It's the first thing divided by that thing. So cos A, cos B, minus sine B, cos A, minus sine A, cos B, plus sine A, sine B. Now when I divide this, I'm timesing by the reciprocal, and so this and this will simplify away. And here I've got cos A, cos B, plus sine B, cos A, plus sine A, cos B, plus sine A, sine B. And I think if you were doing this and you hadn't really thought about what you were trying to do, you might get close to giving up at this point. But look how close we're getting. We're trying to show that when I take tan here over cot here, that the thing I end up with works out to be k here. And you can see k here is just really close to what we've got now. So let's take a look. All I have to do to finish this is I just have to reorder. So if I write this and then this, in the top line, that gives me cos of A plus, no, hang on, wrong. this plus this is cos of A minus B minus sine A plus B, right? Now it's a minus here and a minus here, so that works. And then in the denominator, I'm going to again have this cos A cos B, sine A sine B, and then I'm grouping those two together there. That gives me plus sine of A plus B. Right, now I think that is worthwhile putting into a box, because what we've shown is that that equals K. Let's have a look. We want cos of the difference minus the sum of the sine of the sums, A minus B, A plus B, A minus B, A plus B. Have we got what we wanted? Let's hope we have. Yep, we've got exactly what we wanted. So, ta-da, this equals K. So we have shown, therefore, I bet no one's watching. Right. Right, there's 2 bits of chocolate if you've watched this far. Okay, PowerPoint, the OneNote's going to come back. I just want you to not hang up the phone yet, because we need to kind of get it into the form for the question, right? And here it's all come back now. I think this laptop is slowly dying. So what we've done is we have shown this. And I know that I tell you don't go rearranging things you've got to prove, but this kind of proof structure was a little bit different than a normal identity one, so that's kind of my excuse. So we've shown that this is true, therefore this is true. Okay, so if you are in 13 MCA, please let me know if that all makes sense. I think that's quite a challenging scholarship question, and we might put that into the later questions this year when we get to Trig, because it's very good practice at identities, and it's just a little bit different. So if you have had a go at this question already, I would go through it in the video, and then I would put it away for maybe a week or so and come back to it and see if you can replicate it, and also see if you've got some better ways of doing it that I've missed. And if you find them, just leave me a note in the comments or make a video and upload it.